October 14th, 1944. The rolling fields outside Aachen, Germany. Sergeant William Chen's Sherman lurches forward at 18 miles per hour across a pockmarked meadow. Through his periscope, he spots a German Panzer Four, hull down behind a farm wall 800 yards distant. The Panzer commander sees Chen too, begins the familiar dance. His driver halts. The tank settles. The gunner acquires his target. Chen doesn't stop. His gunner, Corporal James Rodriguez, keeps the 75mm gun trained on the German tank as their Sherman bounces over uneven ground. The hydraulic whine of the gyroscopic stabilizer is barely audible over the engine noise. Rodriguez fires while moving. The round strikes the Panzer's turret ring. The German tank brews up before its own gunner can finish his firing solution. 600 yards away, Hauptmann Friedrich Weber watches through his field glasses, trying to understand what he just witnessed. His doctrine, his training, everything the Panzer School at Munster taught him, says tanks must stop to fire accurately. Moving targets miss. Stationary targets hit. This is physics. This is certainty. But the American tank just killed one of his panzers while racing across open ground at combat speed. Weber has commanded armour since the French campaign in 1940. He's seen Americans fight in Tunisia, in Sicily, in Normandy. Their Shermans are inferior, thinner armour, weaker guns. German doctrine accounts for this. Engage at range, fire first. Win. Except Weber's panzers keep losing to American tanks that shouldn't be able to hit anything while moving. And across the Atlantic, in an Aberdeen proving ground archive room, the after-action reports are piling up. Reports that describe a technological advantage so subtle, so invisible, that German intelligence will spend the entire war trying to decode it. The advantage that turned American tank gunnery from adequate into devastating wasn't a bigger gun or thicker armour. It was an oil-filled gyroscope spinning at 6,000 revolutions per minute, keeping 75mm barrels locked on target while Shermans raced across the worst terrain Europe could offer. The morning of October 13th, 1944, Technical Sergeant William Chen stood in the motor pool at Camp Polk, Louisiana, watching his crew perform maintenance on their M4A3 Sherman. The war in Europe was 9 months old. American armour was pushing toward Germany's border. And Chen, recalled from his posting at Rock Island Arsenal to train replacement crews, understood something most American tankers took completely for granted. Their tanks could do something no other army's armour could manage, fire accurately while moving at combat speed. Chen had spent 1942 and 1943 as an engineering liaison at the Westinghouse electric plant in Pittsburgh, where the stabilizer systems for Sherman tanks were manufactured. He'd watched machinists assemble the Westinghouse mechanism, a hydraulic system built around a spinning gyroscope that kept the main gun elevated at whatever angle the gunner selected, regardless of how violently the tank pitched and rolled across terrain. The system was invisible to anyone who didn't know what to look for. No external components, no obvious modifications, just hydraulic lines running from a gyroscope unit mounted in the turret basket to actuators on the gun mount. When the tank hit a bump and the hull pitched forward, the gyroscope sensed the movement and commanded the hydraulic system to elevate the gun barrel, compensating automatically. When the hull dropped into a depression, the system lowered the barrel. The gun stayed locked on target. Chen walked around the Sherman, running his hand along the hull. 56,000 of these tanks had been built since 1942. Nearly every one carried the Westinghouse stabilizer as standard equipment. American crews trained, with the system from day one, learned to fire on the move as naturally as they learned to shift gears. Most didn't even know their tanks had a capability enemy armor lacked. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. His gunner, Corporal Rodriguez, climbed down from the turret, wiping grease off his hands. Sarge, stabilizers running smooth. Checked the hydraulic pressure, topped off the reservoir. System's good for another 1,000 miles. Chen nodded. James. You ever wonder why we practice firing while moving? Rodriguez shrugged. Because that's how we're trained? Because we can, Chen replied. German tanks can't. Soviet tanks can't. British tanks tried to copy our system, but most of their Shermans don't have it working. We're the only army in the world whose medium tanks can put accurate fire on target at 18 miles per hour cross-country. Rodriguez looked at the 75mm gun, its barrel locked in travel position. The Germans don't have stabilizers? Not in their panzers, not in their panthers or tigers either. Their doctrine says you stop, you aim, you fire. They've got better guns, thicker armor, but they have to halt to shoot accurately. We don't. Chen had read the intelligence reports from Europe. After-action reviews described engagements where Shermans killed German tanks while both vehicles were maneuvering. German crews, trained to expect American tanks to stop before firing, were caught mid-movement by 75mm rounds they never anticipated. The stabilizer advantage wasn't decisive in every engagement. At long range, German guns still overpowered American armor. But at medium distances, 600 to 1200 yards, where most tank battles occurred, the ability to fire accurately while moving changed the tactical mathematics completely. The training schedule that afternoon called for moving gunnery exercises. Chen's crew and 5 others would race across the Louisiana range, engaging pop-up targets while maintaining combat speed. It was the most difficult gunnery drill in armored forces curriculum, and American tankers practiced it routinely. German crews never attempted it because their equipment couldn't support the technique. Chen climbed into the commander's position as his driver, Private Martinez, started the Ford GAA engine. The familiar rumble settled into Chen's bones as the Sherman rolled toward the firing range. Through his periscope, he watched the terrain ahead, rolling hills, scattered timber, ground that would pitch the 33-ton tank violently at speed. Driver, maintain 18 miles per hour. Gunner, prepare for targets at combat ranges. The Sherman accelerated, suspension compressing and rebounding as they crossed uneven ground. Inside the turret, Rodriguez tracked his telescope sight across the landscape, the reticle staying level even as the hull bucked beneath them. The gyroscope was doing its work, invisible and essential. The first target appeared at 700 yards, a plywood silhouette painted to look like a German Panzer Four. Rodriguez acquired it through his telescope, made a slight traverse adjustment, and fired without requesting a halt. The 75mm gun roared. The breech slammed backward. The armor-piercing round caught the target dead center. Hit, Chen called over the intercom. Driver, maintain speed. Gunner, next target. They crossed the range for 40 minutes, engaging 16 targets while moving. Rodriguez achieved 13 hits, an 81% accuracy rate that would have been impossible without the stabilizer system. Chen had seen German gunnery statistics from captured documents. Their crews averaged 35% hits while moving, and German doctrine specifically prohibited firing on the move except in desperate situations. After the exercise, Chen gathered his crew for debriefing. They sat in the shade beside their Sherman, drinking water and reviewing performance. James, you missed 3 targets. Why? Rodriguez checked his notes. Target 7, I rushed the shot. Target 11, range estimation error. Target 14, the stabilizer lagged when we hit that big depression. Took 2 seconds to restabilize. Chen nodded. The system compensates for pitch and roll, but it's not magic. Sudden drops still throw off your solution for a moment. You need to anticipate terrain and adjust your firing sequence. He pulled out a manual, flipped to the technical specifications page. The Westinghouse mechanism uses a gyroscope spinning at 6,000 RPM. When the tank moves, the gyro senses angular change and sends hydraulic pressure to actuators on the gun mount. Response time is about 0.3 seconds for normal terrain, but violent drops or climbs can overwhelm the system temporarily. Private First Class Jackson, the loader, spoke up. Sarge, if this system's so good, why don't the Germans have it? Because stabilization is hard, Chen replied. You need precision machining, quality hydraulics, reliable gyroscopes, and you need to train crews to use it properly. The Germans focused their engineering on gun performance and armor thickness. They assumed tanks would fight from stationary positions. They never invested in fire control systems for moving engagements. Chen had seen the German approach firsthand when he'd examined captured Panzer Fours at Aberdeen. The German tanks had superior optics, better gun sights, more powerful main weapons, but their gun mounts were simple mechanical affairs with no gyroscopic compensation. When a panzer moved, its gun barrel pitched wildly with the hull. Accurate fire while moving was nearly impossible. The American approach traded some gun performance for fire control capability. The Sherman's 75mm M3 gun was less powerful than German weapons, but it could hit targets reliably at combat ranges while the tank maneuvered. In the mathematics of tank combat, first accurate hit usually determined the winner. Speed to accurate fire mattered more than maximum gun power. That evening, Chen wrote a letter to his former supervisor at Westinghouse, describing the training results. "Your gyroscopes are changing how tank battles work," he wrote. "American crews are killing German armor in situations where we should lose. The enemy can't figure out why their superior tanks keep dying to our inferior ones. They don't know about the stabilizer. They think we're just lucky or reckless." He sealed the letter and walked to the orderly room to post it. Outside, the motor pool hummed with activity as crews performed evening maintenance. 50 Shermans sat in neat rows, each one carrying an advantage their enemies would never identify. The quiet revolution in tank gunnery had been accomplished not through dramatic breakthroughs, but through systematic engineering applied to a problem most armies never recognized existed. Across the Atlantic, at the Panzer School in Munster, Germany, instructors were teaching the next generation of German tank commanders the doctrine that would get many of them killed. Halt, acquire target. Fire, move to new position. The textbook approach to armored warfare, rendered obsolete by technology the Germans didn't know existed. October 14th, 1944. 05:30 hours. The morning air outside Aachen was cold enough that breath fogged inside tank turrets. Hauptmann Friedrich Weber stood in his command half-track, studying the American positions through Zeiss binoculars. His battle group, 12 Panzer Four tanks from the 116th Panzer Division, was positioned along a ridgeline overlooking rolling farmland. Intelligence reports said American armor from the 3rd Armored Division was advancing toward Aachen from the southwest. Weber's orders were clear. Delay the American advance. Inflict maximum casualties. Hold until reinforcements arrived. His panzers carried the long-barreled 75mm Kiev 40 litres, 4.8 gun, superior to the American 75 in every measurable way. Muzzle velocity, penetration, accuracy. On paper, Weber's 12 tanks should devastate any American formation foolish enough to advance across open ground. Weber had fought in Russia, where the mathematics of tank combat were simple and brutal. Superior German optics let panzer crews spot Soviet tanks first. Superior German guns let them kill at longer ranges. German crews were trained to use these advantages ruthlessly, engage at maximum effective distance, fire from stationary positions, achieve first-round hits. The doctrine had worked in France in 1940, worked in Russia through 1943. It should work against the Americans, whose Sherman tanks were widely regarded as inferior to German armor, thinner armor, weaker guns. The Americans compensated with numbers, producing 5 Shermans for every German tank, but quantity couldn't overcome quality in direct engagements, where German superiority in optics and firepower should prove decisive. At 06:15, Weber's radio operator reported contact. American armor advancing from grid reference Delta 4. Estimated strength: 1 company. 15 to 20 tanks. Weber raised his binoculars. He could see dust rising from the southwest, the telltale sign of tracked vehicles moving cross-country. He keyed his radio, speaking calmly to his tank commanders. All panzer units, enemy contact bearing 270. Range, 2,000 meters. Prepare for engagement at 1500 meters. Fire only on my command. The German doctrine was precise. Let the Americans close to effective range achieve killing shots with first rounds. The Panzer IV's KOK-40 could penetrate Sherman frontal armor at 1500 yards. The American 75 needed to close to 800 yards for reliable frontal penetration. Weber would use that range advantage to destroy American tanks before they could return effective fire. The American formation emerged from a tree line at 1400 yards. Weber counted 18 Shermans, advancing in a staggered line with proper interval spacing. They were moving fast, perhaps 15 miles per hour, which seemed reckless across the uneven farmland. All units, target American armor, range 1400. Fire when ready. The 1st Panzer fired at 0622. Weber watched the tracer arc across the distance, saw the impact on the lead Sherman's glacis plate. The American tank kept moving. The shot had ricocheted off the sloped armor at that angle. Other panzers opened fire, their 75mm guns cracking in sequence. Most rounds missed. The Americans were moving too fast, presenting difficult deflection angles. And then something happened that Weber's training never prepared him for. The American tanks returned fire. While moving, at 1300 yards range, while bouncing across rough ground at combat speed, Weber watched in disbelief as an American Sherman, clearly maneuvering at high speed, fired its 75mm gun and hit Panzer 412 inches the turret face. The German tank's commander was killed instantly. The crew bailed out. Another Sherman fired while cresting a small rise, the entire tank airborne for a moment. The round struck Panzer 408's lower hull, penetrating the thinner armor and igniting ammunition. The Panzer exploded, turret separating from the hull. Weber grabbed his radio. All units, the Americans are firing while moving. Expect accurate return fire. Do not assume they will halt before engaging. But his tank commanders were already discovering this truth the hard way. The American formation wasn't slowing down, wasn't stopping to fire. They raced across the farmland like cavalry, their guns somehow, staying locked on German positions despite the violent pitching and rolling of high-speed cross-country movement. Weber had never seen anything like it. Soviet tanks that tried to fire while moving sprayed rounds wildly, hitting nothing. The Americans were landing shots at combat ranges while maneuvering at speeds that should make accurate gunnery impossible. Panzer 405 fired at an American Sherman from 900 yards, a perfect stationary shot that should have killed the target. The round struck the Sherman's turret, penetrating but failing to ignite ammunition. The American tank didn't even slow down. Its gun tracked smoothly to the German position, fired once while still moving, and killed Panzer 405 with a shot to the turret ring. Weber's tactical advantage was evaporating. His panzers were stationary, presenting perfect targets. The Americans were moving, their speed making German return fire difficult. And somehow, impossibly, the American tanks were landing accurate shots, despite their movement. Within 8 minutes of first contact, Weber had lost 4 tanks. The Americans had lost 2. At 0635, Weber ordered his battle group to withdraw to secondary positions. His panzers backed down the reverse slope of the ridge, breaking visual contact with the American formation. The engagement had contradicted everything Weber knew about armored warfare. American tanks weren't supposed to hit targets while moving at combat speed. It violated the fundamental physics of tank gunnery. As his command half-track retreated toward Aachen, Weber tried to understand what he'd witnessed. His after-action report would describe American tanks firing accurately while maneuvering, but he had no explanation for how this was possible. German intelligence had never mentioned any American technological advantage in fire control systems. The captured Shermans examined at German testing facilities showed no unusual equipment. Weber didn't know that those captured Shermans had been early production models from North Africa, built before the stabilizer system became standard. He didn't know about the Westinghouse mechanism, didn't know about the gyroscope spinning at 6,000 RPM, didn't know that every Sherman rolling off American production lines carried a fire control advantage his panzers would never match. He only knew that the tactical mathematics he'd relied on since 1940 no longer worked against the Americans, and that realization, spreading through the Wehrmacht as similar reports arrived from other sectors, represented the invisible erosion of German tactical doctrine by technology, the enemy never advertised and German intelligence never identified. 400 yards behind the American advance, Sergeant William Chen stood in his Sherman's commander position, surveying the battlefield through his periscope. His crew had achieved 3 hits during the engagement, all while maintaining combat speed. The stabilizer had performed exactly as designed, keeping their 75mm gun locked on target despite the violent terrain. Chen's driver, Private Martinez, spoke over the intercom. "Sarge, those German tanks kept stopping to shoot, made them sitting ducks." "That's their doctrine," Chen replied. "They don't have stabilizers. They think accurate fire requires stationary shooting positions. It's what they teach at their armor schools." Rodriguez, the gunner, traversed the turret slowly, checking for additional targets. "So, we've got an advantage they don't know about?" "Exactly. And because they don't know about it, they can't counter it. German crews keep using tactics that worked against Soviet and British tanks, but our Shermans can do something their equipment can't match." Chen had studied German tank design during his posting at Rock Island Arsenal. The Germans had superior metallurgy, better armor plates, more powerful guns, but they'd never invested in fire control systems for moving engagements. Their engineering philosophy assumed tanks would fight from prepared positions, using superior optics and gun performance to dominate at range. The American approach was different, except that Sherman armor was thinner than German equivalents, except that the 75mm gun was less powerful than German weapons, but compensate with mobility and fire control that let American tanks engage effectively while maneuvering. The stabilizer made this possible, turning the Sherman into a platform that could shoot accurately in situations where German tanks had to remain stationary. The tactical implications were profound. In open terrain where German guns had range advantage, American tanks could close distance rapidly while maintaining defensive fire. At medium ranges where most engagements occurred, American crews could maneuver aggressively, using speed and movement to complicate German firing solutions, while their stabilized guns stayed locked on target. Chen watched as recovery vehicles moved forward to retrieve damaged Shermans. 2 tanks from his company had been knocked out during the engagement, but both crews had survived. The thin armor that German guns penetrated so easily also meant rounds often passed through without igniting ammunition. American tankers learned to accept the trade-off. Better to have penetration without catastrophic fire than thick armor that burned completely when finally defeated. At 0700 hours, Chen's company commander, Captain Morrison, called him to the command post. Morrison stood beside a map table, marking German positions. "Good work this morning, Sergeant. Your crew's stabilizer discipline was excellent. 3 hits, all while maintaining speed." "Thank you, sir. The system worked as designed." Morrison nodded. "I'm getting reports from all across 3rd Armoured. German tanks are staying stationary during engagements. Makes them easy targets when we can fire on the move." "Intelligence," says the Germans don't understand why we're hitting them so consistently. "They don't have stabilizers, sir. Their doctrine assumes everyone stops to shoot accurately. And as long as they keep assuming that," Morrison said, "we keep winning engagements we should lose on paper. Your Sherman's outgunned and under-armoured compared to a Panzer Four, but you can hit him while moving and he can't return fire effectively until he stops. That's a hell of an advantage." Chen understood the mathematics. In a stationary duel, the Panzer IV's superior gun should win, but tank combat rarely involved stationary duels. It was dynamic, chaotic, fought across terrain that favoured mobility. The stabilizer let American crews exploit that chaos, turning their tank's speed into a tactical weapon that German doctrine couldn't counter. "Sir, are we going to tell the Germans about the stabilizers?" Morrison smiled grimly. "Sergeant, we're not even telling our own replacement crews what makes the way. System special. Most tankers just know they can fire while moving. They don't know the Germans can't. The longer the enemy stays ignorant, the longer we keep our advantage. Chen returned to his Sherman and gathered his crew for maintenance. Rodriguez was checking hydraulic pressure on the stabilizer system, ensuring the mechanism was ready for the next engagement. "Sarge," Rodriguez asked, "how long do you think before the Germans figure out we've got stabilizers?" "Maybe never," Chen replied. "The system's invisible unless you know what you're looking for. And even if they captured a Sherman with the mechanism intact, they'd need months to reverse engineer it and years to manufacture their own versions. The war will be over by then." He was right. German intelligence would spend the rest of the war trying to explain American tank gunnery effectiveness, never identifying the Westinghouse stabilizer as the source. Reports would describe American tanks firing recklessly, while moving attribute hits to luck or suicidal bravery. German doctrine would continue recommending stationary firing positions, turning panzer crews into predictable targets for American tankers who could maneuver freely. The October sky was clearing as Chen's company prepared to advance deeper toward Aachen. 18 Shermans, each one carrying an advantage the enemy would never decode. The quiet revolution in tank gunnery continued, invisible but decisive, changing the mathematics of armored warfare one engagement at a time. The German Army's Technical Intelligence Service, the Waffenamt, received its first detailed report about unusual American tank gunnery on November 3, 1944. The document, filed by Hauptmann Friedrich Weber after the engagement outside Aachen, described American Sherman tanks achieving hit rates of 60 to 70% while moving at combat speeds across rough terrain. Weber's report was precise and professional. He noted engagement ranges, terrain conditions, American formation tactics, and the disturbing fact that Sherman crews appeared to fire as accurately while maneuvering as German crews did from stationary positions. His conclusion was carefully worded. American tank gunnery has improved significantly since North Africa. Crews demonstrate unusual proficiency in moving engagements. Recommend investigation of potential fire control improvements or specialized training programs. The report joined 17 similar after-action reviews from other sectors of the Western Front. Panzer commanders from Normandy to the Ardennes were describing the same phenomenon. American tanks firing while moving, hitting targets they should miss, refusing to halt before engaging, contrary to every principle of effective tank gunnery. At the Kummersdorf testing facility south of Berlin, German engineers received instructions to examine this problem. They had access to 3 captured Sherman tanks, all pulled from battlefields in Italy during early 1944. The engineers conducted exhaustive tests, measuring gun accuracy while the tanks maneuvered across test ranges. Their results confirmed what German doctrine predicted. Accuracy while moving was terrible, rarely exceeding 20% hit rates at combat ranges. The captured Shermans behaved exactly as German tanks did. When stationary, they achieved acceptable accuracy. When moving, their guns pitched wildly with the hull, making precise fire nearly impossible. The engineers filed their report in December 1944, concluding that American gunnery improvements resulted from superior crew training rather than technological advantages. German High Command accepted this assessment. Training could be countered with doctrine. If American crews were practicing moving gunnery extensively, German tank commanders would simply engage at longer ranges where movement made accurate return fire impossible. What the Kummersdorf engineers didn't know was that all 3 captured Shermans were M4A1, models built in early 1943, before the Westinghouse stabilizer became standard production equipment. The tanks they tested represented American technology from 18 months earlier, before the gyroscopic revolution reached frontline units. German intelligence was analyzing obsolete equipment and drawing conclusions that would get their tank crews killed. Meanwhile, at the Westinghouse electric plant in Pittsburgh, production of stabilizer mechanisms continued at maximum capacity. The manufacturing floor ran 3 shifts, producing 60 stabilizer units daily. Each mechanism required precision machining to tolerances of 1/1000th of an inch. The gyroscope assembly alone contained 47 separate components, all manufactured to specifications that demanded the highest quality American machine tools could deliver. Martha Davidson worked the second shift as a quality control inspector, checking every stabilizer unit before it was approved for installation. Her job required measuring hydraulic pressure tolerances, testing gyroscope spin rates, and verifying that servo motors responded within acceptable time parameters. She'd been doing this work since early 1943 and understood that each unit she approved would eventually sit in a Sherman tank turret, keeping some American crew alive in combat. The workers at Westinghouse knew their product was important, but most didn't understand exactly how the stabilizers changed tank combat. That information was classified, shared only with engineering staff and military liaisons. Martha knew the gyroscopes helped tanks aim while moving, but she'd never seen combat footage or read after-action reports describing how crews used the system in actual engagements. On November 15, 1944, the plant received a visit from Technical Sergeant William Chen, recalled from Europe for 2 weeks to consult on stabilizer improvements. Chen walked the manufacturing floor with the plant manager, examining production processes and discussing field performance. When he reached Martha's inspection station, he watched her test a gyroscope assembly, her practiced hands checking each specification with methodical precision. "Ma'am," Chen said quietly, "I commanded a Sherman in the 3rd Armored Division. The stabilizer you're testing right now, or one just like it, kept my crew alive through 8 engagements. We could hit German tanks while moving at 18 miles per hour. They couldn't hit us back because they had to stop to shoot accurately. Your work is saving American lives every day." Martha looked up from her test equipment, seeing for the first time the direct connection between her inspection duties and the survival of men like Chen. "Are the Germans trying to build their own stabilizers?" she asked. Chen shook his head. "They don't even know we have them. German intelligence thinks we're just reckless or lucky. They keep using tactics that assume we fight like they do, stopping to aim before firing. Every day they stay ignorant. More American crews come home alive." The invisibility of the stabilizer advantage was its greatest strength. American tank crews used the system naturally, incorporated it into their tactical approach without consciously recognizing it as unusual. German crews observed American behavior and attributed it to suicidal aggression rather than technological capability. Neither side advertised the disparity, and German intelligence lacked the context to identify what they should be looking for. December 1944 brought the German offensive in the Ardennes, the massive assault that would become known as the Battle of the Bulge. SS Panzer divisions, equipped with Tiger and Panther tanks, smashed through American lines, creating chaos and confusion across a 50-mile front. For German commanders, the offensive represented a final opportunity to exploit what they believed remained American tactical weakness, the supposed inability of Sherman tanks to match German armor in direct combat. SS Obersturmbannführer Joseph Dietrich, commanding the 6th Panzer Army, issued tactical guidance to his tank commanders that reflected standard German doctrine. Engage American armor at maximum effective range. Use superior German optics and gun performance to achieve first-round kills. Maintain stationary firing positions to maximize accuracy. The guidance made no mention of American fire control capabilities or the possibility that Sherman tanks might engage effectively while maneuvering. The weather initially favored German operations. Heavy fog and snow reduced visibility, negating American air superiority and forcing tank combat into close-range encounters where German armor advantages should prove decisive. But the same weather that grounded American aircraft also created terrain conditions that turned the stabilizer advantage into something even more pronounced. Staff Sergeant Robert Hayes of the 7th Armored Division found himself fighting near St. Vith on December 17th, his Sherman operating in conditions that would have paralyzed German gunnery. The roads were iced, the fields covered in snow that hid ditches and obstacles. His driver, Private Carson, was navigating by compass and memory, maintaining 8 miles per hour through terrain that pitched the 33-ton tank violently. Through his periscope, Hayes spotted a German Panther tank 600 yards distant, positioned hull down behind a stone wall. The Panther's commander had chosen a perfect defensive position, but the German tank was stationary, waiting for the Americans to halt before opening fire. Hayes didn't halt. "Gunner, target Panzer, 600 yards, traverse right, fire when ready." His gunner, Corporal Jackson, acquired the target through his telescope sight. The reticle stayed locked on the Panther's turret, face even as their Sherman bounced over hidden ruts beneath the snow. The stabilizer compensated automatically, keeping the 75mm gun elevated precisely despite the hull's pitching. Jackson fired while they were still moving. The armor-piercing round struck the Panther's gun mantlet, penetrating and killing the German gunner. The Panther's return fire came 8 seconds later, after its crew recovered from the shock of being hit by a moving target. The German round missed wide, the gunner's replacement struggling to acquire a moving target through optics designed for stationary engagements. Hayes's second shot caught the Panther in the lower hull, igniting ammunition. The German crew bailed out into the December snow. Across the Ardennes battlefield, similar engagements were occurring dozens of times daily. German tank commanders, executing doctrine that assumed American tanks would stop before firing, found themselves taking accurate hits from Shermans that refused to halt. The tactical advantage that German planning had counted on, superior gun performance and armor protection, was being negated by American mobility and fire control capability. Hauptmann Weber, now commanding a composite battle group of Panzer Fours and Panthers, filed another report on December 23. American tank tactics continue to emphasize movement and aggressive maneuvering. Enemy crews demonstrate unusual accuracy while firing from moving platforms. Our defensive positions, effective against Soviet and British armor, are proving less successful against American formations. Recommend development of counter-tactics that account for American gunnery capability. The report was filed and forgotten in the chaos of the German offensive's collapse. Weber's recommendations never reached the tactical training establishments that might have acted on them. German doctrine remained frozen around assumptions that had become obsolete, and American tank crews continued exploiting an advantage their enemy couldn't see or understand. By January 1945, the Battle of the Bulge was over. German armor had been decimated, losing over 600 tanks in a month of brutal fighting. American losses were significant, but recovery rates for damaged Shermans remained high. Tanks that took hits while maneuvering could often be repaired, their crews surviving to fight again. The stabilizer had contributed to this survival rate in ways that never appeared in official statistics. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Technical Sergeant Chen returned to Europe in February 1945, rejoining the 3rd Armoured Division as it pushed toward the Rhine. His crew had received a new Sherman, a late-production M4A3, with improved armour and the latest version of the Westinghouse stabilizer. The mechanism had been refined, based on field feedback, with faster servo motor response and more robust hydraulic seals that could withstand the punishment of sustained combat operations. Chen gathered his crew in the motor pool at Duren, walking them through the stabilizer's capabilities one more time. Most of his crew had been with him since training, but they'd received a new loader after their previous man rotated home. Private First Class Miller was 19, fresh from stateside training, and he'd never fired a shot in combat. "Miller," Chen said, pointing to the hydraulic lines running through the turret basket. "These lines connect to a gyroscope. When we're moving and the hull pitches, the gyroscope senses it and adjusts the gun elevation automatically. That's why we can hit targets while driving at combat speed. The Germans can't do this. Their tanks don't have stabilizers. When they move, their guns move with the hull. They have to stop to shoot accurately." Miller looked skeptical. "Sarge, I've seen German tanks. Panthers, Tigers. They're way better than Shermans. Thicker armor, bigger guns. How do we win against that?" "We win by fighting smarter," Chen replied. "Yes, their tanks are better on paper, but we can move and shoot at the same time. They can't. So we use speed and maneuver to get into positions where their advantages don't matter. We close the range fast, fire while moving, and hit them before they can stop and aim properly. Rodriguez, the gunner, demonstrated the stabilizer in action. He trained the gun on a distant tree, then ordered the driver to rock the tank back and forth by revving the engine. The hull pitched forward and back, but the gun barrel stayed locked on the tree, the hydraulic system compensating automatically. "See that?" Rodriguez said. "That's what keeps us alive. The Germans see us bouncing across a field, think we can't possibly hit anything, and then we put a round through their turret. They never expect it." The division's next objective was crossing the Ruhr River, a opposed assault against prepared German defensive positions. Intelligence reported that the Germans had positioned armor in hull-down positions covering the approach routes, classic defensive doctrine that maximized their range and armor advantages. American planning called for artillery and air support to suppress the defenses before armor attempted the crossing, but weather grounded the aircraft, and ammunition shortages limited artillery support. The crossing would have to be forced primarily with armor and infantry, Sherman tanks leading the assault against German positions that should have massacred them. Chen studied the tactical maps and understood immediately that this was exactly the kind of engagement where the stabilizer advantage became decisive. February 23, 1945, 0500 hours. The Ruhr crossing began in darkness, combat engineers throwing pontoon bridges across the river, while German artillery pounded the crossing sites. Chen's Sherman was in the third wave, rolling across a swaying pontoon bridge while shells exploded in the water around them. The bridge flexed and pitched beneath the tank's weight, but Chen kept his crew focused on the far bank. "Driver, maintain steady speed. Gunner, prepare for targets immediately after we clear the bridge. They'll have guns positioned to cover the exit points." The Sherman rolled off the pontoon bridge onto the eastern bank at 0532. German positions opened fire immediately, pre-registered artillery and direct-fire weapons converging on the crossing site. Chen's driver accelerated to maximum speed, racing away from the killing zone while the gunner searched for targets. Target, Panzer, 800 yards, hull-down position behind rubble, Rodriguez called out. Chen could see it through his periscope, a Panther positioned perfectly to dominate the approach. The German tank had clear fields of fire and excellent protection. Doctrine said the Panther should destroy any Sherman attempting to advance across open ground. But Chen wasn't following doctrine. "Driver, maintain speed, zigzag pattern. Gunner, fire when ready." The Sherman was racing across muddy ground at 22 miles per hour, dodging shell craters and debris while the gunner kept his telescope locked on the Panther. The stabilizer system was working hard, compensating for violent terrain and evasive maneuvers. Rodriguez waited for the optimal moment, watching his reticle track across the Panther's position, then fired. The 75mm round caught the Panther in the turret ring, the one point where armor thickness dropped below the Sherman's penetration capability. The German tank's turret jammed, unable to traverse. Before the Panther crew could respond, Chen's loader had another round chambered. Rodriguez fired again, hitting the same point. The Panther brewed up, smoke pouring from hatches as the crew bailed. Out. Behind Chen, 2 more Shermans cleared the bridge and engaged additional German positions using the same tactics. Move fast. Fire while maneuvering. Hit the enemy before they can establish stable firing solutions. The German defensive plan, built around the assumption that American tanks would halt before firing, collapsed as Sherman crews poured across the Ruhr and engaged immediately. By 0700 hours, the 3rd Armoured Division had established a secure bridgehead. German armour had been forced to withdraw after losing 5 tanks to the initial assault. American losses were lighter than planners had anticipated, 3 Shermans knocked out but with most crews surviving. The stabilizer advantage had proven decisive in exactly the kind of engagement where American armour should have been slaughtered. Chen's after-action report, filed that evening, noted the stabilizer's performance in combat conditions. System operated flawlessly, despite violent maneuvering and poor terrain. Crew was able to engage enemy armor immediately after bridge crossing without halting to establish firing position. Recommend emphasis on moving gunnery tactics for river crossing operations. The report joined thousands of similar documents flowing through the American Armored Forces command structure. The cumulative evidence showed that Sherman crews equipped with functioning stabilizers achieved hit rates 30 to 40% higher than crews whose systems were damaged or disabled. The technology was changing the tactical mathematics of tank combat, but the change was so gradual and so widely distributed that no single engagement made headlines. March 1945 brought the final collapse of German resistance in the West. American armor raced across Germany, covering distances in days that should have taken weeks. The speed of the advance was possible, partly because German defensive doctrine continued to emphasize stationary fighting positions that American mobility could bypass or overwhelm. Panzer commanders trained to fight from prepared positions found themselves constantly outmaneuvered by Sherman formations that could engage effectively while moving at speeds German tanks couldn't match. At the Kummersdorf testing facility, German engineers were still trying to understand American tank gunnery effectiveness. They'd acquired a newer Sherman, an M4, a 3 captured near Cologne in March, and immediately noticed differences from the earlier models they'd tested. This tank had additional hydraulic lines in the turret, equipment the engineers couldn't immediately identify. Oberleutnant Hans Richter, the facility's chief technical officer, supervised the examination personally. His team traced the hydraulic lines from the gun mount to a spinning mechanism in the turret basket. When they powered up the tank's electrical system, they could hear a high-pitched whine as the mechanism began rotating. "It's some kind of gyroscope," Richter said, watching the device spin up to operating speed, connected to the gun mount through hydraulic actuators. His assistant, a mechanical engineer named Klaus Weber, tested the system by rocking the tank back and forth with a crane. As the hull pitched, the gun barrel remained level, compensating automatically for the movement. "Herr Oberleutnant, this is a stabilization system. It keeps the gun elevated regardless of hull angle. The Americans can fire accurately while moving because their guns don't pitch with the hull." Richter understood immediately what this meant. Every tactical report describing American tanks hitting targets while maneuvering, every engagement where Shermans had engaged successfully from moving positions, every German tank knocked out by fire that shouldn't have been accurate, all of it explained by a technology German intelligence had never identified. "How long have the Americans had this capability?" Richter asked. Weber examined the tank's data plate. This Sherman was manufactured in September 1944, but the stabilizer system looks like mature technology, not a recent innovation. They've probably had this for years. Richter wrote his report that evening, March 16, 1945. He described the stabilizer mechanism in detail, explained how it provided fire control capability that German tanks lacked, and recommended immediate development of similar systems for Panther and Tiger production. The report was filed with the Waffenamt in Berlin, where it sat unread as the German government collapsed around it. The war ended before German tank design could incorporate lessons learned too late. American armored forces finished the European campaign with nearly 60,000 Shermans in service, almost all equipped with the Westinghouse stabilizer. German armor ended the war using the same fire control systems they'd started with, mechanical gun mounts with no gyroscopic compensation. The statistical evidence of the stabilizer's impact emerged in post-war analysis. American tank crews reported hit rates of 45 to 60% while firing on the move at combat ranges. German crews, when forced to fire while moving, achieved hit rates of 20 to 35%. British crews, operating Shermans that often had non-functional stabilizers, reported hit rates similar to German figures. The technology advantage had been invisible to casual observation, but decisive in cumulative effect. Thousands of engagements where American crews hit targets they should have missed. Thousands of situations where German crews missed shots they should have made because their targets refused to remain stationary. The mathematics added up to American tactical superiority that German doctrine never understood or countered. Technical Sergeant William Chen mustered out of the army in November 1945, returning to civilian life in San Francisco. He took a position with the Westinghouse Electric Corporation, working as a field engineer supporting gyroscopic stabilizer production for the Navy's post-war programs. The technology that had saved his life in tank combat would find new applications in naval gun directors, aircraft weapon systems, and eventually the inertial guidance systems that would power the space program. On a cold morning in December 1945, Chen visited the Westinghouse plant in Pittsburgh, where Martha Davidson was still inspecting stabilizer mechanisms on the production floor. The war was over, but the plant had contracts to produce stabilizers for export to Allied nations and for American tanks being refurbished for potential service in the Pacific before Japan's surrender. "Miss Davidson," Chen said, extending his hand, "I came by to thank you personally. The stabilizer you inspected back in November 1944 ended up in my tank. It worked perfectly through 16 engagements. My crew is alive because you did your job, right?" Martha shook his hand, seeing clearly now the connection between her precision work and the survival of men like Chen. "Did the Germans ever figure out what we had?" "Not until March 1945, Chen replied. "German engineers finally examined a captured Sherman with the stabilizer intact. By then, the war was almost over. They spent 4 years fighting against a technology they didn't know existed. We were hitting them with shots they thought were impossible, and they kept assuming it was luck or aggression instead of engineering. The invisibility of the advantage had been its greatest strength. American crews used the stabilizer so naturally they barely thought about it. German crews observed American behavior and misinterpreted what they saw. And between those two perspectives lay a technological gap that changed the mathematics of armored warfare without ever becoming visible in newspaper headlines or propaganda films. The stabilizer represented applied engineering translated into tactical advantage. A gyroscope spinning at 6,000 RPM, hydraulic actuators responding in fractions of a second, precision manufacturing that turned theoretical capability into battlefield reality. The system hadn't won the war by itself. No single technology ever did. But it had saved thousands of American lives while helping defeat an enemy who never understood what they were fighting against. In the archives of the panzer divisions that fought in France and Germany during 1944 and 45, after-action reports describe American tanks firing recklessly while maneuvering. The reports attribute this behavior to suicidal aggression or desperation, never identifying the gyroscopic stabilizer that made accurate fire while moving not just possible, but routine. German tactical doctrine continued, recommending stationary firing positions until the last weeks of the war, turning panzer crews into predictable targets for American tankers, who could maneuver freely. The cost of this intelligence failure was measured in destroyed German tanks and dead crews, men who fought bravely using tactics rendered obsolete by technology their commanders never recognized. Hauptmann Friedrich Weber survived the war as a prisoner, captured near the Rhine in March 1945. In post-war interviews, he described the frustration of watching American tanks hit targets while moving at speeds that should have made accurate fire impossible. "We thought they were reckless," Weber said years later, firing wildly while driving at combat speed. "But they weren't reckless. They were using technology we didn't have. Every time we stopped to aim properly, we became stationary targets for crews who could shoot accurately while moving. Our doctrine killed us, and we never understood why until the war was over." The Sherman tank's reputation in post-war years focused on its thin armor and weak gun, the visible characteristics that made it seem inferior to German armor. But the tankers who fought in Shermans understood what the specifications didn't show. The M4 could do something no other nation's medium tanks could manage: fire accurately while racing across the worst terrain Europe could offer, hitting targets that crews in other armies would have missed, surviving engagements that doctrine said they should lose. The Westinghouse stabilizer, invisible to external examination and unknown to German intelligence, represented American engineering philosophy at its best. Accept limitations in gun power and armor protection. Compensate with fire control technology that let crews exploit mobility and speed. Turn battlefield chaos into tactical advantage through systems that worked automatically, requiring no special skill or training beyond standard crew procedures. Production of Sherman tanks ended in 1945 with the M4A3E8 model, the final evolution of a design that had proven more adaptable than anyone anticipated in 1941. The last Shermans rolled off assembly lines with improved armor, better guns, and the same Westinghouse stabilizer that had been standard equipment since 1943. The gyroscope that German intelligence never identified remained in service with American armor through the Korean War and into the 1950s. Technical Sergeant Chen's final contribution to the Sherman program came in January 1946, when he wrote a technical paper for the Army's Ordnance Department describing how crews used the stabilizer in combat. The paper, classified for 20 years, detailed the tactical advantages of moving gunnery and recommended that future American tank designs incorporate even more sophisticated stabilization systems. The gyroscopic stabilizer gave American armor a decisive advantage that enemy forces never identified. Chen wrote, "Crews learned to exploit this capability naturally, incorporating movement into their tactical approach in ways that contradicted enemy expectations. The result was American gunnery effectiveness that exceeded performance predictions based purely on gun and optics specifications. Future tank designs should emphasize fire control systems as strongly as armor and firepower, recognizing that the ability to hit targets reliably matters more than maximum gun performance." The paper's recommendations influenced American tank development through the Cold War. The M48 Patton tank that entered service in the 1950s carried stabilization systems for both the main gun and the secondary weapons. The M60 that followed incorporated even more sophisticated fire controls, computers and laser rangefinders working with gyroscopic stabilizers to provide accuracy while moving that would have seemed impossible to World War II tank crews. But the Sherman stabilizer remained the foundation, the first successful application of gyroscopic fire control to mass-produced armor. 60,000 tanks carrying a technology advantage their enemies never decoded, fighting battles where physics and engineering mattered as much as courage and tactics. The memorial at the National World War II Museum in New Orleans includes a Sherman tank, turret traversed slightly right, gun elevated at combat angle. The data plate shows it was manufactured in Detroit during September 1944, one of thousands that carried the Westinghouse stabilizer into battle. Visitors walk past without recognizing the hydraulic lines in the turret basket, the mechanism that made this particular Sherman different from every German tank it fought against. The crews who fought in these machines understood what the specifications never captured. The Sherman wasn't the best tank of World War II in gun power or armor protection, but it could do something that mattered more in actual combat. It could hit what it aimed at while moving fast enough to survive, and that capability, invisible to everyone except the men who depended on it, helped win the war in Europe one engagement at a time. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.